Unit 2, Objective 1, Literal Equation Notes. We're going to start the notes with practicing how to solve different types of equations. 1a is a proportion, and we solve proportions by cross multiplying. So we're going to multiply across this way with an equal sign in between. So 3 times x minus 8 and 2 times x plus 4. So now we've turned it into a regular equation where we distribute and move the variables to one side and the numbers to the other. So that's x equals 32. For the second one, we see that we have a fraction in front of the x. So we begin by subtracting 5 from both sides. 2/3 x equals 4. And to remove the fraction in front of x, we do the process of multiplying by the reciprocal of the fraction. And we do that on both sides. When you multiply a fraction times its reciprocal, everything divides away to 1. On the other side, you're going to have 4 over 1 times 3 over 2, which is 6. The third one's just regular straight up solving. You're going to add the 2x to the other side. You're going to subtract the 12 to the other side. And when you divide by 7, you end up with a fraction. Leave your answers as fractions. If you turn them into decimals, they will be repeating or non-repeating long decimals. You won't know where to cut them off. Leave as a fraction. Okay, evaluating literal equations. So we're going to read the problem and figure out what we're supposed to do. Jose decides he needs to lose weight, so he hires a personal trainer. The trainer charges for each workout an initial fee of $30 plus 50 cents per minute. His fee can be represented by this equation. Okay, so this is the equation we're going to work with. X is the number of minutes. That's important for you to know what the variable represents. How many minutes? So we're looking for X. Did Jose work out if he was charged $52.50? So $52.50 is going in for C, 30 plus 0.5x, and then just normal solving. So minus 30 minus 30. 52.50 minus 30 is 22.50 equals 0.5x. Divide by 0.5, divide by 0.5. And he worked out for 45 minutes. Number 3, a person walks on a treadmill, finds that her number of paces, p per minute, again, know what the variables represent, can be modeled by this equation. M is the number of minutes. P is paces. To the nearest whole number, what is her pace rate at the end of a 30-minute workout? Okay, so P equals 60 minus root 2 times 30. So 30 minutes goes in for M. You're going to type that in your calculator. 60 minus the square root of 60. Turns out to be about 52.25. It said to the nearest whole number, so that's 52 paces. Now we're going to move on to solving literal equations. In order to solve literal equations, you need to think about the very first time you learned how to solve an equation. So for the first one, we know that we have to get x by itself. So we're going to add 10 to both sides because in the problem it's subtracting 10. So we do the inverse operation. So 4x equals 40. This is 4 times x, so we do the inverse operation of multiplying, which is dividing. So x is 10. In the second equation, we are solving for x again, but if we look, we see other variables in the equation. You're going to follow the same steps. You want to get x by itself. So I'm going to add 2w to both sides. But when I add 2w to the right side, I can't combine it with 14z, non-like terms. So 5x equals 14z plus 2w. You're still dividing by 5 because you're trying to isolate the variable. And when you come to the other side, you divide everything by 5. So the answer here is x equals 14z over 5 plus 2w over 5. look at the answer. It's not a single number because you had variables to begin with. You have already learned how to solve for a particular variable when you worked with equations of lines. So when you convert from standard form to slope-intercept form, you do this process called solving for a single variable or literal equations. So in the first one, we're going to solve for y. So we're going to subtract 5x from both sides. So that's going to be negative 2y equals negative 5x plus 20. Divide by negative 2, divide by negative 2, divide by negative 2. That means our answer is y equals positive 5 over 2x minus 10. So we've converted it from standard form to slope-intercept form, and what we've done is we've isolated y. We have solved for y. In the second one, we're going to add 3x to both sides because there's a minus 3x. That's going to give us 6y equals 3x minus 6. We're isolating y, so we're dividing by the 6 in front of y, and we do it to every term in the equation. Then we reduce the fraction, 3 over 6, 1 over 2x minus 1. So now we're going to take that process and we're going to connect it to solving for a single variable when there are multiple variables in the equation. So let's look at the first one. P equals 4s minus 3t. We're going to solve for s. So it's helpful to actually highlight what you're solving for so that you know you're isolating that. All right, I'm going to add 3t here because the process or the equation says minus 3t, so you want to do the inverse operation. So that's going to be p plus 3t equals 4s. And again, don't change the case. So if it's an uppercase, keep it in uppercase. So I went and fixed that. Okay, divide by 4, divide by 4, divide by 4. So capital P over 4 plus 3t over 4 equals s. All right, next one, we're going to solve for x. So x is right here, and x is surrounded by a 2 and a y. So if I divide by 2y on both sides, those will divide away, and I'll get x equals a over 2y. A common equation that we work with when we're doing literal equations is the equation to convert from Celsius to Fahrenheit. C stands for Celsius, F stands for Fahrenheit. Solve this formula for F. So I'm going to rewrite it over here. So C equals 5 over 9 times F minus 32. So the first thing I'm going to do is I'm going to undo the fraction. So I'm going to do what I did in that other problem, and I'm going to multiply by the reciprocal on both sides. When you multiply 5 over 9 times 9 over 5, they divide away because they are reciprocals. So it turns into 1. On the other side, we're going to get 9 over 5c equals, and then because these guys divide away, the parentheses may be dropped, and you're going to get f minus 32. Add 32 to both sides, and you get 9 over 5, capital C, plus 32 equals capital F. Do not lose the case. It's uppercase letters. Yesterday, it was negative 7 degrees Celsius. What was the temperature in Fahrenheit? So I'm going to put negative 7 in for Celsius, 5 over 9, F minus 32, right? So I could solve for F this way, right? Or I could actually take the negative 7 and put it right here. So 9 over 5 times negative 7 plus 32 equals F. So you're going to go to your calculator, and you're going to go 9 over 5 times negative 7 plus 32, and that is 19.2 Fahrenheit. Error analysis. Find the error when solving for the indicated variable. All right, so in this equation, which is an equation that comes from geometry, we're going to solve for the r variable. All right, so the first thing that we're going to want to do is we are not going to want to subtract negative 2 pi because 2 pi is multiplied by r squared. So the inverse operation should be dividing. So here I found it in the very first step. So where is the error? So s equals 2 pi r squared. We should be dividing by 2 pi. So that's going to be s over 2 pi equals r squared. And now let's discuss the inverse operation of square. That is square rooting both sides. So we're going to square root and square root. That leaves us with the square root of s over 2 pi equals r. Number 8, solve the equation for b1. So again, it's helpful if you highlight the variable that you're solving for. Now you can't get to the inside of the parentheses until you get rid of the stuff on the outside of the parentheses. So I see an h over here, so I'm going to divide both sides by h. So now I've got a over h equals 1/2 b1 plus b2. Well, here we have a fraction again, so I'm going to go ahead and multiply by the reciprocal of 1/2 because that's going to allow us to cancel the 1/2. So remember, multiplying by the reciprocal turns it into 1. So now I've got 2a over h equals, and now I'm allowed to drop the parentheses, b1 plus b2. Well, now in order to solve for b1, all I have to do is subtract away the b2. So 2a over h minus b2 equals b1. Number 9, solve for g, right? So look where g is. All right, well, the first thing I'm going to do is I'm going to rewrite it so that I can work with it. So f equals g m1 m2 over d2. So the first thing I'm going to do is I'm going to multiply both sides by d2. Why would I do that? Because look what happens. The d2's cancel. So now I've got f d2 equals g m1 m2. Now, if I'm going to solve for g, all I have to do is divide away the m1, m2. And when I wrote that f d2, I realized we need to write our variables in alphabetical order. D comes before f, so this should be g equals d2 capital F, m1, m2. Okay, number 10. We're solving for a different letter now. We're solving for m1. But it's basically the same thing that we just did, right? So we're going to begin by multiplying both sides by d2. So that's going to be d2f equals g m1 m2. But now since we're solving for m1, we're dividing by g m2. So now we've got d2f over g m2 equals m1. Lots of letters, so just keep track. All right, the last type of problem that I need to show you is when the variable shows up twice and you can't combine it to a single like term. What do you do? Okay, here you have to factor. What do I mean by that? Well, in number 11, we're solving for x, and x is in both of those terms, but I can't put those terms together. And so I'm going to factor as if it were the GCF of the equation. So I'm going to factor out the x, leaving me with 5b plus 7a. That's called factoring. But notice I took the variable from from two terms to one term. Now to solve for x, all I have to do is divide by the whole expression, 5b plus 7a. Because watch what happens. This whole thing divides with this whole thing. And x equals 15 over 5b plus 7a. You can leave the parentheses or you can drop them. Okay, one more showing this idea of factoring. It says solve for x. Okay. X on the left side, x on the right side. Let's actually put those variables on the same side. So I'm going to subtract the 15x over to this side. So I'm going to have wx minus 15x. And then I'm going to add the 7a to the other side. Equals 7a plus 10b. All right, now look, I cannot add those two terms together. You cannot add a wx and a 15x. They're not like terms. But what I can do is pull the x out. Factor as if it were the GCF. That's going to leave me with w minus 15. Now you're going to divide by what's in front of the x, or next to the x, I should say. Put parentheses, don't put parentheses, it doesn't matter. And you're going to have, look, those divide away. You're going to get x equals 7a plus 10b over w minus 15. Last problem is a challenge, and it says solve for h. So h is right there. Oh, h is also right here, right? But also it has a 1/2 a and a 1/2 b, right? Well, let's just factor it out. So if I pull the h out, I'm going to have 1/2 a minus 1/2 b. Well, if I divide, it's going to look weird. It's going to be 1/2 a minus 1/2 b, and then 1/2 a minus 1/2 b. And even though those will divide away, this looks weird. So it is recommended to begin the problem by multiplying by 2. That's why it's a challenge. Multiply by 2 to start, right? So that would mean 2a equals, and if you multiply this by 2, guess what? The fractions go away. 2 over 1 times 1 over 2 is 1. So 2a equals ah minus bh. Now you can do your factoring, and you get 2a equals h, a minus b, and so 2a over a minus b equals h. And that's your answer. So look at, this is the preferred answer, as opposed to the first one. You should never leave fractions in the denominator. That's it.